All right, finally we have some idea of how far a Taylor polynomial can get from its original function. What we found in the last video was that if we have some control over the n plus first derivative, if the n plus first derivative never gets bigger than m on the interval from a to x, then the difference between the Taylor polynomial at x and the function at x is definitely no bigger than m over n plus 1 factorial times the absolute value of x minus a to the n plus 1. So for our first example for this situation, let's start with a function we know something about. Let's use sine. And let's also choose our favorite base point, 0. And for the x value, let's say 1. And for the order, let's say we're going to use the order 3 Taylor polynomial for sine. Now, based at 0, we actually know the order 3 Taylor polynomial for sine. You can work this one out if you want. It's x minus 1 over 3 factorial times x cubed. So the actual value that this Taylor polynomial produces when we put in 1 is 1 minus 1 over 3 factorial, which is 6, so 5 over 6. Okay, but you know, 1 is not a nice input for sine. It's an extremely bad input for sine. So we don't really know, we wouldn't know before now, how far off this 5 over 6 actually is. So to get some idea of how far off it might be, let's use our error bound for the the order 3 Taylor polynomial at 1, and compare that to the original function at 1. Now, if we pretend that we don't have scientific calculators, we have no idea of knowing how large this difference might be. So we have to use the Taylor error bound. If we knew this error exactly, we could just add the error to the approximation and get the exact value of sine of 1. So we don't know how big this is, so we'll use the Taylor error bound. This error is less than or equal to m over, remember n is 3, so 3 plus 1 factorial times the absolute value of x, which is 1, minus the base point, which is 0, to the n, which is 3, plus 1. So this is all going to be m over 4 factorial, which is 24. But first we need to figure out what m is. So what is m? Remember, m is some bound on the n plus first derivative of f. And what is the n plus first derivative? Well, remember, our function f is just sine. So the fourth derivative, 4 little tick marks, fourth derivative is, well, fourth derivative of sine is sine. So how big does this function, sine of t, ever get? The biggest it ever gets is 1. So we need to choose some value for m that makes this inequality work. We need to pick a number that we're calling m to put into this box. And we know that this function, the n plus first derivative, is sine of x, or sine of t. So what is the biggest sine of t ever gets? Well, it's 1. So we can choose m equals 1. So way up here in our error bound, take our m value, put it in there, we get 1 over 24. So the error between the approximation, 5 over 6, and the actual value is definitely no larger than 1 over 24. For having to add together only 2 terms in our Taylor polynomial, getting as close as 1 over 24 is actually pretty good. especially considering that our x value 1 was pretty far from our base point at 0. In our next example, we'll look at another way we can use the Taylor error bound.